Hey comrades, Wags here from Eagle Dynamics. In this DCS Mi-24P video, we'll explore how to hover, taxi, and take off in the Hind. There are several variants of these that we'll review, and these are based on the actual Mi-24P flight manual. Although these are by-the-book procedures, you may find a procedure that works best for you. These are some of the most challenging things you can do in a helicopter, but you also get a great sense of pride and accomplishment once you have mastered them. Let's get started. Alrighty then. So before we jump into the meat of this video, let's go ahead and do a little housekeeping first. Let's close the door with the handle here. And in the previous video, we talked about the pressure valve knob here. And what this actually does is that it's sealing the doors of both the pilot door, the operator door, as well as the cargo bay, because the Hind is actually an NBC protected helicopter, a nuclear biological chemical. So right now we see down here that the doors are unsealed. So what we're going to do is we're going to rotate the pressure seal counterclockwise to set those seals, and now we see the doors are sealed. Also, an item from the previous video, I had more than a few, just a couple thousand people asking why I didn't shut off the APU once the engines were up and running. That's because actually the APU did shut off automatically, which was a mistake. What happened is in an earlier version, the electrical system was actually drawing too much electrical power from the buses to power the autopilot systems. And for the sharp-eyed of you, you may have noticed some of the lights here on the electrical panels are actually flashing, indicating that we were actually not having enough voltage in the system, and actually kicked off the APU automatically. Since then, we've rectified that and should be working quite well at release. So next, let's jump into the outside of the aircraft and talk about some basic fundamentals. As you can see, the rotor disc is tilted forward. This provides a more comfortable in-flight attitude. To hover, though, we'll need to level the disc by using aft cyclic. Because the main rotor blades rotate clockwise, the body of the aircraft will want to rotate counterclockwise. We'll use a tail rotor to counteract this using the anti-torque pedals. Because the tail rotor pushes the aircraft to the left, we'll encounter translating tendency. This is countered with right cyclic. The aircraft will weather vane into the wind due to the vertical tail, and this is called weathercocking. When hovering, and ideally when taking off, make sure the nose of the aircraft is pointing into the wind when the wind speed is below 16 knots. Above 16 knots, position the aircraft to have the wind hit at the right side at about 45 degrees. Let's jump into the pilot seat now. Let's zoom into the instrument panel and take a look at the instruments that we'll be using today. First, we have our airspeed indicator in kilometers per hour. Below that, we have our two altimeters. And for the hovers, we'll be really using the one here more on the left. The one here on the right is more for the higher altitudes. To the right, we have our VVI, or vertical velocity indicator, in meters per second. To the left is our Doppler drift indicator. And if we have a good hover, we should not be seeing any white lines either forward, back, left, or right. As we start to drift in one of those directions, we'll have a white line starting from the center out in the direction of the drift, with each tick mark indicating 5 kilometers per hour. And down here in the corner, we have our collective position in degrees. And if we are using the Doppler drift indicator, we want to make sure that the Doppler switch is in the up position. And while we're back here, let's go ahead and turn on the blinker. So if the blinker is off, a warning light would be a solid red. If the blinker is on, that light will flash and also have an audio indication, which will be much better at grabbing your attention. Just in case we run into some rain today, let's test the wiper. The wiper is wiping. Coming in the map, let's zoom in so we can better see our route. And when I'm doing a hover, I like to have a point of reference through the gun sight, so I'm going to actually turn on the sight. Coming back down to the autopilot system, let's turn the collective off. So you can think of the autopilot system much like a SAS system or a stability augmentation system in a more modern Western aircraft. And that's going to help dampen the controls and just make the aircraft a whole lot easier to fly. However, when you're first starting out, you very well may wish to disable these. Mainly because when you don't have that augmentation, you're getting a much more accurate and real feel to what the aircraft wants to do, and it just gives you a much better appreciation for the handling qualities of the aircraft. But for today, I'm going to go ahead and engage these, so I'm also going to turn on the altitude, pitch, roll, and of course yaw. Now, during the course of this mission, I'm going to be talking a lot about my cyclic, anti-torque pedals, and the collective. So I'm going to turn on the controls indicator here in the top left corner. The right side is what my cyclic is doing. Below that are the anti-torque pedals. And to the left is the collective. The flashing B indicates that the wheel brakes are on, which is also indicated by the red light down here. But what I'm going to do next is I want to disengage those wheel brakes before I do a hover test. Mainly because if I start to pull collective for a hover and I start to generate a lot of translating tendency, with that wheel locked, it may pivot on that wheel and roll the aircraft for a rotor strike on the ground, which would be a pretty bad day. So what we're going to do is we're going to find a good neutral position for our controls, use the force trim to set that, and then release the brakes, find a good center position, and use that for a hover check. So what we talked about earlier about the rotor disc being tilted forward, we need to compensate for that first. So we're going to go aft on the cyclic to have the rotor disc nice and level with the ground. Then I'm going to go just a little bit off here to the right to compensate for the translating tendency from the tail rotor. And now I'm going to hit the force trim button, and I'm going to keep it right there. So that's going to be my new center point for my controls. Now if you want, you can also go to the options and also set your anti-torque pedals to be force trimmed as well. It's up to you. So at this point, this is a pretty rough estimate where I think the controls need to be. And once I release that brake, in all likelihood, I'm going to have a little bit of movement. And what I'll be doing is adjusting those controls and resetting the force trim so I have a nice steady position. So here we go. Brake off. Just actually pretty good. Little yaw to the right, little to the left to counteract. Reset. I'm feeling pretty good about that. Great. Next, let's test this, and we're going to pull about 5 degrees of collective, 5.5. And we're going to see that the nose is a little going to the left now, tiny bit, counteract to the right, retrim. And at this point I have a nice, good, steady position, and we're ready to do our hover check. So when we do a hover check, when we take advantage of what's called the ground effect. And the ground effect is essentially a cushion of air below the aircraft, which is one diameter of the rotor length. In this case for the Hind, rotor length is 17.3 meters. So we'll have a ground effect from 0 up to 17.3 meters, with the ground effect lessening from 0 to that 17.3 meters. First, we'll gently pull the collective such that the yaw autopilot channel, indicated by the H in the top right corner, can catch up to the collective input. Once stable with light on wheels, slowly increase collective and correct for drift with the cyclic as needed. As collective is increased, the yaw autopilot channel will try to compensate. Use a Doppler position gauge and near-field references like the asphalt to judge forward and back drift, and the weapon sight against those power lines ahead to judge drift left and right. Let's now intentionally drift to the right to see what that looks like on the Doppler position gauge. You can see the white line that we're drifting to the right about 10 kilometers per hour. Now we'll come back the other way, and we're also moving forward about 5 kilometers per hour. Back to the left, counteract the other way, and center up. When descending in a hover, do not exceed a negative vertical velocity of greater than 2 to 3 meters per second with a heavy load to avoid a vortex ring state in which we lose lift. Okay, now let's learn how to taxi. Because the Hind has tricycle landing gear, we can either use the wheels to taxi on prepared surfaces, or we can do a hover taxi over unprepared surfaces. Either way, we'll want to do a hover check first to find that good neutral trim position. Let's first review a rolling taxi. Disable the yaw dampeners first with the switch here so we have better control when taxiing on the ground. After ensuring that the wheel brakes are off, apply a little forward cyclic to get moving forward, add cyclic to slow down, and the anti-torque pedals to steer left and right. Once moving forward, be careful when using the wheel brakes to avoid a tail strike. And if moving backwards with aft cyclic, never use the wheel brakes, as that will probably result in a tail strike. As for a hover check, after doing our hover check first, we'll hover again to about 3 to 5 meters off the ground. And once established, we'll go forward on the cyclic a little bit to establish some forward airspeed. And to turn, we'll do a combination of using the anti-torque pedals and the cyclic left and right while coordinating the side slip with the ball underneath the ADI in the center of the instrument panel. As we push the runway, I'm going to pull back a little bit on the cyclic to slow down and decrease the collective to land. And I'll be going over this in much more detail in a dedicated landing video for the Hind. And once down, I'm just using the anti-torque pedals now to point myself down the runway. And with that, we set ourselves up for a rolling takeoff, which we'll look at now. So when taking off the Hind, we can do it in one of two general ways, a rolling takeoff and a hover takeoff. But in both cases, we want to first do a hover check, not only to find a good neutral center trim position for the aircraft, but also to do an engine power test before taking off, of course. Now in the back of the right console, we have our air conditioning system. And not that anyone probably really cares, but yeah, we do have a fan if you want to turn that on. Alrighty, so the by-the-book method is cyclic forward, and we'll be looking for about 20 to 30 kph. Once that's attained, we'll center the cyclic, increase collective, and using the anti-torque pedals to do our best job keeping down the center of the runway, and also using the cyclic left and right once we get airborne. Okay, we are up. Next thing we're looking for is about 15 meters or so of altitude, keeping within our ground effect. And And once we're about 15 meters or so, we'll go again forward on the Cyclic to gain airspeed. And now we'll be looking for 70 kph, at which we'll raise the landing gear. And at this point, we're in a flyaway condition. So as you can see, taking off from a runway in the Hind is quite easy, and this would be your ideal method, particularly when you're heavily loaded. So next, let's take a look at the hover takeoff. With the hover takeoff, as you might have guessed, the first thing we need to do is our hover check. Once we do that, there are two general variants of a hover takeoff we can do. We can either do it in the ground effect or outside the ground effect. In this case, we're actually on a helipad, so actually it's a bit of a combination of the two. So we're going to increase our collective and go back into a hover again and maintain a hover about 3 to 5 meters off our ground surface. Okay, once established, we'll pitch forward. And because we came off a helipad into a higher altitude, we'll have to give a little extra collective. And again, we'll be looking for 70 kph to raise the landing gear. And next, at about 100 kph, we can back off the throttle a little bit. As you'd probably imagine, an in-ground effect hover takeoff is ideal if you have a heavy loaded aircraft and you have no obstacles around you. But if you do have obstacles around you and you need to hire to a higher altitude above the ground effect, then the outside of ground effect hover takeoff is the ideal method. And this concludes this overview of how to hover, taxi, and take off in the Hind. Now, I didn't go too deep into the Y aspects, but there's some really excellent Mil-8 videos that I'll link to in the video notes that delve into this much more deeply. So, hope you enjoyed this video, and in the next video we'll get into the pew 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 and discuss the unguided weapons delivery. I'll see you next time. Thanks.